Hi. Okay, so now what? So what if I did this? Oh, hey, look at that. All right, so we're going to be talking about the abacus. Now, with the abacus, we're going to be doing these. That's really interesting. Okay, so here is my abacus, and we're going to be talking about my book. And then there's this book. So we do 1, 2, 3, 4, and then 5. We have 6, 7, 8, 9, and then 10. Hi, everybody. Welcome, welcome, welcome. I'm hoping you guys can hear me. I actually forgot to check to see if you can hear me on the microphone. Yes, you can. Great. Okay, so the question is now I want to do is, what is this strange thing? This strange thing is an abacus, and this abacus helps me count. But we can also do adding, subtraction, and multiplication and division. And I have to remember to look in the camera. I have been doing just, doing the abacus for so long that I forget that I have a camera on. The one that, can see my face. So I am so happy that everybody's here. Thank you for joining me. And then, so the first thing we're going to do is we're going to count on the abacus. So we do the ones place, right? So this is how I know is because there's a dot over here. This dot tells me that I get to choose which dot. So I can use this dot or this dot. This dot means it's going to be the ones place, and then this dot here can also be the ones place. It just depends on how big your numbers are going to be. So we're going to just count for right now. So we're going to do 1, 2, 3, 4, and then 5. This top bead will always be 5. So this is 5, this is 5, this is 5, this is 5, and that's 5. All of these blue beads, all the top beads actually, top beads is considered 5. And now you're going to notice that I use my hands a lot. So I don't know if it's a good thing or a bad thing that you get to see my face. So now the thing is when we do 5, right? We have 5. We could do 6. Hi everybody, welcome. Hi. Let me know if you have any questions. And we're just talking about the abacus and how it's interesting that we can utilize a manipulative, this is a manipulative, to teach the children or teach us to have a stronger sense of numbers. And it's actually quite easy. The first thing we all need to do is we need to all understand how to read the abacus. I didn't start learning how to read the abacus when I was, a child. I actually learned the abacus when I was a lot older. So we're counting. So this will always be 5, and then this will be 6. So we have 5, 6, 7. We have 8. 5, 6, 7, 8. Thank you so much for liking my live. Go ahead and if you can, share it so that everybody else can understand how to use the abacus and this strange little concept. What is this strange tool? It's a really, really cool tool. So we have, I think it's better than sliced bread. Okay, so we have 8, right? How do I know? 5, 6, 7, 8. And then 9. You know what? We will start adding on the abacus. I just want to make sure that we all understand how to read the abacus. When we start going and understanding how to read the abacus, we're going to go right into understanding how to add on the abacus. And then I was looking at some adding strategies, which was kind of interesting. And I was like, wow, it would be so much easier to do it on the abacus. So the first thing we're going to do is we're going to understand that this is the ones place. We have the ones place, the tens place, the hundreds, the thousands, and the 10,000. Thank you so much for the likes. Thank you. If anybody has any other questions, but we will continue on. And then when we understand how to read the abacus, then we're going to go into addition. Okay, so what does that mean? Well, if you notice, I have this one book that I created, and this one was about for children who needs to understand what their numbers are. So it starts from the very beginning on how, what the number 0 is. Oh, that was the thing, is in school, we don't teach the kids to start from 0, which is kind of interesting. We actually teach the kids to start from 1. But on the abacus, we actually have to teach the children from 0. Why? Because 0 gives me a nice, clean abacus. Hi everybody, where do we get that? Well, you can either get this abacus on my website or you can get it on Amazon. You can go to learningwithlynette.com, or this is the book. This book is available on Amazon. Look for Lynette Young. I should write my name. So, if you did a search on Amazon for my name, you will see my books. Okay, so if you want the book, that's what it is. And I should put my name there, but it's not on this book. Anyways, so we're talking about, and then that was the thing, is on the abacus, on the book, I show you how what the abacus is and how to read it. And so we talk about this is the picture, right? There's a picture, there's a representation, there's the symbol, and then there's the physical. So if you have the physical, it's actually nice to see because then the kids can move the abacus and the beads. So all the lower beads has a value of 1. All the upper beads has a value of 5. And so why do we have a value of 5? So we can count more. And that is the interesting part. I was actually thinking about rounding. So some of the kids have problems with rounding, and Abacus really helps because if you notice, we do 1, 2, 3, 4. Anything less than 4, you go down, right? But if you go 5, which is up here, then you roll up. Oh, so I was thinking about that. I was like, oh, so Abacus does a lot more than just counting on the abacus. It shows shows the children how to do um, rounding up or rounding down. So we have 5. So just to continue counting, we have 5, 6, 7. Right? How do I know? We have the 5. The top bead will always be 5, and the 2 beads is always going to be a value of 1. So when we add 2 beads, this is 7, and then we have 8, and we have 9. So then what do? We have 10. Well, where does 10 come from? Well, just like how we write on the paper, if I can get my paper, maybe I don't have my paper. If we get a paper, where's my pen? Where's my, here it is. So just like how we write, in our, just like how we write, just like how we write, we have our 10. So then I'm going to use this marker and I'll do 10. So if I do 10, right, we know that this is tens, right? And then we know this is ones. So then, when we put it on the abacus, notice we have our ones place, which is 0, and we have our tens place, which is the 1. So that's how we do it. So then when we do 11, notice I do 1 and 1, and then 1 and 2. But Abacus also extends itself to doing place value. And it's really quite interesting that in school, some children have a hard time with understanding what the symbol, right? The symbol of the number is. But on the abacus, it's right there. It's easy to see. So this is where when they start counting on, it's easy for them like, oh, if I add this number, it will be 13. It'll be 1 and a 3. If I add one more, it'll be 14. It'll be 1 and a 4. So then we have 15 and then 16, 17, 18, 19, and 20. So now we're at 20, which is 2 and a 0, which is interesting. So then from here, we're able to do counting, right? We have counting. And so then, so this is 2, right? 2 and a 0. Then this, what number do you think this would be? If we were to say that this is the ones, the tens, the hundreds, please put in the chat um, what this number would be. Anybody know what this number would be? Hi, Whitney. We're just trying to figure out what this number is. So we have our ones, our tens. Yes, exactly. Exactly. Whoa, where's my number? I don't know if anybody heard. 30, it is not 30 because there's 2 here. So there's 2 beads here. And it's also, when you look at it, it'll be ones, tens, hundreds. So when we look at the abacus, we have our ones, tens, hundreds, and then thousands. 30 would look like this because it would be the tens and the ones and the tens. The ones and the tens, and then there would be a 3 on the tens. So, so that was really good. When we do the number, right? Let's say I did this number. What number do we know? What number do you think this one is? Thank you again for so much to follow. What does the one? Oh, so the ones on the top bead signifies as 5. So no matter where we are, this will always be a value of 5. So when we count, we have 1, 2, 3, 4. Notice I don't have enough beads, right? So in order to get the 5, we actually just use the top bead, and this is 5. This will always be 5. So we have 5 and 5 and 5 and 5 and 5. But notice that depending on where the column is, that would be the other zeros, right? So how do I know that these are zeros? Well, if you notice, none of the beads are touching this horizontal bar. When the beads touch the horizontal bar, that is when we know we count it. So when we know that these are zeros, we do the 1 bead on top, and that's the 5. Yeah, fantastic. Thank you, thank you, thank you. Yeah, let me know if you have any questions. We'll continue on. So then we count it on. We do 6, right? How do I know? Because it's 5 and a 6 and then 7. 5, 6, 7. Now, when you look at it, what we're really looking at is we're looking at two beads, right? We're looking at the 5, which is 5 and then plus 2. So that equals to 7. The kids, when they start learning this, they actually learn how to count it. They don't understand that they're actually adding. But on the abacus, it's easy to see that we're adding. So we have 5 and we have 4. 1, 2, 3, 4. We do 5 plus 4 is equal to 9. And it's interesting because now the kids will actually start seeing the patterns of the numbers. Because in the funny, not funny, but interesting part is that now the school, I'm not sure. I mean, I was doing some research, and a lot of a lot of my videos that I've been looking at when they start doing math, they do a lot of diagrams. So there's this one where they were talking about number bonds, and they started doing. I think she did 38, right? And she did, I think, 18. So here we can start adding. And so she broke it up into 1 and 8. Because what is it? It was tens over here and the ones over here. And then 8 and then 3. That's great. That's great. But it'd be kind of the same thing on the abacus. So on the abacus, if we're going to add, well, let me do that. Okay, yeah. If we're going to add, right, we're going to do 38. We do 3 and then we do 8, right? That's 38, 38. So we have our ones and we have our tens. So now the next step we're going to do is we're going to add the tens together. That is where we go here. So all we got to do is add 1. So we add the 1 and then we have to add 8. This is a little bit more complicated because now we need to know the two-step equations in math, in abacus. There's more steps in abacus than just adding, right? There's actually understanding the 5 frame, the 10 frame, and so forth. So for right now, let me continue on with adding the 8, and we're going to start with the basics, not the basics, the fundamentals that everybody who learns the abacus needs to understand. So let me continue on. What we're going to do is we're going to add the 8. So I need to plus the 8, I'm sorry, minus the 2, and then plus the 1. And my answer would be 56. So having said that, let's continue on with something a little bit more fundamental, understanding why we do this. So the other thing that I noticed, I was doing some research on adding and subtracting with with regular school, with mainstream school. And I noticed that what they do is they focus in on the result. So here's a question. We have 7 plus 1. Well, on the abacus, it's easy to see. We have 7 and we have plus 1. Easy. I mean, that's, But notice what I did notice is in the video, they were bouncing the 8. So they were really focused on the result. It's different because on the abacus, we actually focus on the second add-in. That's what it's called, second add-in. So we do 5 plus 3. That one is easy because we've done that before, right? We do 5, and then we add the 3. Okay, that is not a problem. That's easy. But again, the video said, okay, you know what? The answer is 8. Great. Okay. Now, the next question, it was 4 plus 4. Now, interesting about 4 plus 4 is in abacus, we don't learn doubles. We don't learn our doubles. What we learn is how to add this second add-in. And using the terminology that the math terminology, second add-in. This is the second add-in. This is the first add-in. This is the second add-in. First add-in. I don't even know how they get these names. And then the second add-in. Okay, second add-in. Okay. So we in abacus focus on the second add-in. Now why? Because if you notice here, if I add 4, which is the first add-in, right? Oh, I can't do that. I can do that. Okay, yeah. So I have 4, but notice I don't have enough beads to add 4. So what do I need to do? Well, this is where the 5 frame comes into effect. What is the 5 frame? In school, not everybody, but in school they're teaching children how to do, what does 5 mean? Let me get something. Okay, in school, they're teaching children with like manipulatives, which is interesting. I mean, I like manipulatives, right? So an abacus is a manipulative and these blocks are manipulative. Okay, so what do? They say, okay, well, to make a five, right? To make five, how do you split it? I do 1 and 4, right? Or I could do 4 and 1. So the equation is 4 plus 1 is equal to 5, or 1 plus 4 is equal to 5, right? If I color these in, I have 4 and then 1. So that's something that the kids will know. That's something that they are going to be learning. However, in Abacus, we take it one step. The idea is to utilize this 5. This 5 is what helps us. We take the whole thing, right? And we're going to add the 5. But notice it's too much. We can't add the whole thing. So if I did, I think I could do it like this, okay? So when we add the 5, it's too much, right? We only need to add 4. So what happens? Well, we got to take 1 away. So 1 goes away. Did that make sense? So then my answer is 8. I hope that makes sense. We can expand. Let me expand on it a little bit more. So let me do it again. So this is the other book. So now what we're doing is we're talking about the plus 5 with who. And we're talking about the second add-in, which is the 4. So in this book, I focused on just the second add-in because I want everybody to see it can be children. This book was geared towards children. So I wanted to show the children what was the scenario when you add the 4. So if you look at it, we have, let's do this one because it's easier when it's not 1. So we have the 2, so I add the 2, right? But now what I said is in here, I made it into a little story and I said, okay, I want to add 4, but there's not enough beads to add the 4. This is where the issue is, right? We don't have enough beads, so we need to find another way. Well, to find another way, what we're going to do is we're going to go to the cats in the tree. We're going to go to the cats in the tree to grab 4 cats. Okay, so we go to the cats in the tree, which is the top bead. We go to the cats in the tree and we grab 4 cats, but 1 cat runs away. So I'm trying to but I'm trying to add a story to adding the 4. So if you notice, it's add the cat, go to the cats in the tree, and then take away the 1. 1 cat runs away. So if you notice, there is a number pattern that happens. I take 1 bead on top and 1 bead on bottom, and I move them down. Do you see that? So I'm actually adding 4 like this. So my answer is 6. So that's what I have here. Does that make sense? Let me know if that makes sense. But I'm going to continue on to the next question, which was 3 plus 4. So again, we do 3. Hello, welcome. Oh, fantastic. Fantastic. It just says Apple user, blah, 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 blah. Oh, fantastic. Yeah, right? So easy. Abacus makes it so easy. So, but these are the building blocks, right? These are the building blocks that the children or just everybody. When I was learning it, I had to learn it, but I didn't learn it with stories. This is a story that I made up. So, but we're going to continue on. We're going to do, because you know what it is? It's also about practice. And that was the thing is like, let's just practice. Oh, sorry. We'll just practice what adding 4 is. We don't learn our doubles. So again, we don't need to learn doubles plus 1 or doubles minus 1, right? That's a strategy that's being taught. We don't need to learn that. You can. I'm not saying don't. You can. But in Abacus, we don't. How does those kids do the super fast stuff? Oh, yeah. So the super fast stuff, I have no idea the logic behind the toy that you have. Oh, yeah. So this is actually not a toy. It's a tool. It's a counting tool. It's a calculating tool. How do the kids do it super fast? You know, honestly, the kids do it super fast. They go through rigorous questions of adding and subtracting on the abacus multiple times for hours on end. I mean, if you want to, you could, but my goal wasn't to produce children that does competition abacus. I wanted everybody who comes on board to look at abacus to be, this is the greatest thing next to sliced bread. And I'm hoping that this would spread the word. Why? Because it helps with understanding, like physically understand how the beads move. I doing competition math, it's great. If you want it, you can go down that route. But that wasn't where my heart is. My heart is to trying to get you to, hi, hi, Babel. My goal was to try to show everybody how easy abacus is and how we can build number sense and strong math skills. So then when children, because abacus is the gateway to more complex math. So, can you? Yes, I will explain. So, here is the explanation of the logic behind the tool. Thank you so much for recognizing it's a tool. How do you choose which bead to move, and how do they be how when what do they represent? Yes. So these are the beads. You're absolutely correct. And so if you notice all the bottom beads, what is considered bottom? Anything underneath this horizontal bar is considered the bottom bead. So with the bottom bead, we have a value of 1. So we have 1, 2, 3, 4. Did that make sense? So, and here, okay, so we know that this is 1, this is 2, this is 3, this is 4. That's fine. So this is 4, this is 4, this is 4. Let me slow down. This is 4, and then this is 4. I get so excited because I'm very passionate about abacus. Okay, and sometimes I talk a little bit too fast. So okay, so we have 4. Now the difference between the two, right? The difference between this one and this one is that there's a 0 here. How do I know? Because if you notice, there's a dot here. This dot tells me that I'm going to use this as the ones place. With the ones place, with the ones place being labeled, you can use any one to be the ones place, but it's nice that this is already labeled for you, so you don't have to really worry. You could use this one as a ones place, but then what happens is, because we're doing place value, your decimal will be here. That means your number can be really small. If you use this one, your numbers will be very large, if that makes sense. So continue on. Oh, so this is 4 and this is 4. But the difference between this 4 and this 4 is the place value. This is 4. This is 40. And then 400, 4,000, 40,000. So then notice if I go back to here, there's not enough beads to add the 5. There's not enough beads to count one more. Right? So that's why we have the top bead. How do I know it's the top bead? Anything that's above the horizontal bar is considered the top bead. And this top bead, when it touches this horizontal bar, is counted. And when it's counted, this is considered 5. So when we continue on, we can start seeing that when we add the 1 bead at the bottom, now we know that this is 6. And then this is 7. How do I know? 5, 6, 7. We add the 5 and we add 2. And then we have 3. 5, 6, 7, 8. 5 and 3 makes 8. And then we have 5 and 4 makes 9. Did that make sense? Pollo? Is it pollo? I'm hoping I say that right. Because I know a Spanish word that says pollo, but I don't know what the 2 dots in the I don't think they're called umlauts. Okay, good. Okay, good. So if that made sense, so that's how we read the abacus. And so when you join, of course, not a problem. Let me know if you have any questions. Because no questions is dumb except you don't ask. If you don't ask a question, then that's a dumb question. Please ask all the questions about understanding what this tool is. And if you're okay with like using you could use it as a toy. My kids, when they were small, they would make it into a car and they would be running it around like this. The other one was used as a massager. That's what it was. It was a back massager, but they're very small beads. All right. Let me hold on. Let me go turn on some lights. I'll be right back. All right. And I was getting a little warm. Okay, so we're back to here. No, here. No, here? No, I'm trying to readjust the work. Okay, I would like to get the abacus. Where do you get that one from? You can either get it from my website, which is learningwithlynette.com, you could go to learningwithlynette.com, or you can get it on Amazon, which is fine too. These are made. This one is made out of plastic, and depending on how old you, I mean, I like it colorful. I like it colorful, but there are others. Just so you know, there's this one. Okay, so this one is 1, 2, 3, 4, 5, 6. I should write it down. This one has 7 columns, right? Do you have a site for gener for generate calcula? How do you reset it? Oh, reset it. I'm not. I'm sorry, Stephen Nietzsche. I don't understand that question. How do you reset it? Hi. In CMS. I think I see the CMS. So I think it's in CMS. So reset it. You tilt it forward, so all the bottom beads, all the top beads go to the horizontal bar. You tilt it, and then you take your finger, which is the back part of your back part where the nail is, and you push everything up like this. Make sure you hold the abacus with your left hand, because if you don't, then all the the kids will move the abacus, and then your beads are all messed up. So the idea is you have your left hand and you hold it, you tilt it, and then you move it all the way up like that. Yeah, that's how you reset it. Or you get one that has a button. Let me see if I can find one with a button. No. Yeah, this one. You can get one with a button, and you can reset it like this. But this one's more expensive. How does it work? See, if you look, it does that. It does it for you. Hi, Jules. So you can get one with the button. Oh, but anyways, for a manual one, what I would do, because the kids also like it, where they just tilt it and they move it up. And if you notice, it's so you can hear the AMSR. And it's kind of cool. There was a time where we had like a bunch of students, and we did a math competition within them, amongst them, not within them, amongst them, and all you hear is the kids moving the beads. It was cool. Oh, we'll get into subtraction in a little bit. I just want to explain a little bit more about the extra tools. From right to 50. A site for practice. I have books to practice, but they're more right now. They're geared towards young children because they're activity driven, and I do have like questions within them. If that's okay, I do have a bunch of TPT worksheets that I kind of update and stuff. Sorry, let me go back to my thought on the abacus. So you can get this one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You can get the 13 one. The reason why I'd probably get this one for the older kids, because one, it's a single color, and they can have bigger numbers. Notice with the 13 column one, I would start from the middle. So here is my abacus, and I'd start from the middle, and then I would have all these beads to be big or all these beads to be small. And so, I mean, this one was more for the younger kids, and I was kind of focusing on that. But as my students go through, I would graduate them to something like this. You could get them a bigger one like this. This is, I think, 21 or 23 columns. But I wouldn't. I mean, it's rare. It's rare. Do you have a number this big? I mean, unless you decide to do abacus competitions. So, all right. So I'm sorry, Deborah. I don't understand when you said the right 40, 50. Oh, okay, yeah. So no, I get it. So you're right. So we do. So if I start right here in the middle, and we're going to do subtraction in a little bit, Jules. I did not forget about you. I just lost it. Sorry, I'm looking at it. Okay, so from the right, so if we start from here, we do 4, right? Not 14. 14 would look like this because it's a 1 and a 4. It would be 40 like this if it was a 4 and a 0, right? 50 would be the top bead like that. Did that make sense? So when we read the abacus, the numbers are all the same on each column. It just depends on which column it is. It's ASMR. Yeah. I get some. So those kids that do math fast, that's how they do it. Yeah. So when the kids do it in their heads, they're most likely most, like, what am I saying? It's usually the abacus, and they have it in their head and they do it multiple times and they do it like hours on end, and so they can get fast, which is great. But my goal was to make sure that the kids have strong math foundations so they can go further on, like, say, algebra, calculus, trigonometry, and so forth. And so I believe, and that's why I'm here to talk about math terminologies with the abacus, because the abacus and math is just really hand in hand. Yes, 40. So, no, no, a site who generates numbers. No, I don't know any site that generates the numbers with the abacus. And I haven't built one yet. But I do plan on building one because the numbers are very specific with the abacus. So I do appreciate the idea. But yeah, we don't I have a site that does have questions, but you would have to be part of the it's not a free site. You would have to join my site. And I haven't and we do so in my class. What we do is we do numbers that kind of does the questions right there, or we actually have it say it to the children, have it say it to our students. And so what it is was to build their hearing as well as their visual. So yeah, I there's not a one that generates. I do have one that has the computer generated. So how to do subtraction? Let's do that. So the first thing we can do is in the I'm going to use this one. Sorry. So what happens with subtraction? It's not very difficult for the students to see what subtraction is. Why? Because when we do 35, or no, let's do 38. When we do 38 and we take away 1, right? We take away 1, they know to move the 1 bead like that. So as they move the bead, they know how to take it away. So let's say take away 3, it's easy, or take away 5, easy enough. I just take away the 5. I just move it away from the bead, from the horizontal bar. So let's go and take this into effect. Let's do the now. Before I continue on, we need to understand it's still the 5 frame, right? It's still the 5 frame, but now we have to do with the minus. When we do with the minus, instead of saying plus the 4 is equal to plus the 5 minus 1, we actually go minus the 4 is equal to minus the 5 plus the 1. How did this work? Well, we have to change. We did 4 plus 1. If you think about it, it's plus 4 plus 1 is equal to plus 5, right? This is the adult version. It's for you to understand what I'm talking about, right? I don't show this to the students because they don't need to understand the logic behind it. But it's better for us to understand, like, why are we doing it? So when we do it, we want to have it reversed. We do minus the 4 minus 5. Oh, I'm sorry. No, I'm sorry. Minus 4 minus 1 is equal to minus 5. So now we're dealing with negatives, right? We're dealing with negatives, which is not a problem. But now what we need to do is when we want to take away the 4. So if I had, if I had the number, let me do an easy number. Oh, here it is. Okay, let's do 15. So we do 15. 15, I'm sorry, 15, right? Take away 4. So we're at 15, take away 4. That's what we're doing. So notice I do minus 1 minus 4 minus 5 equals minus 5. So let me rearrange this just like what we did here, right? When we added, I'm going to take this 1, I'm going to move it over here. To do that, I need to plus the 1. So what does that mean? Well, when we have 15, right, we have 1 and a 5, and I want to take away 4. There's not enough beats to take away the 4. So now we're stuck. No, we're not. We can utilize this 5. To do that, I want to if I want to take away the 4, right, we're doing a substitution, which is another math term that I'm starting to understand. So we do a substitution, right? And we change it to say minus 5 is equal to plus. So we're taking this and we're substituting it into this right here. So what we're going to do is we're going to take away the 5 and then add the 1. Notice, I don't know if that worked. Yeah. So notice I do exactly the same, but the opposite. So when we added the 4, we went down plus the 5 minus the 1. When we take away, it's actually plus the 1 minus the 5. Okay, so I hope that makes sense. So is it possible to do multiplication? Yes, it is very much possible to do multiplication. Multiplication is being done by distributive properties. So in school, in Abacus, we actually don't learn, we don't, no, we memorize, but we don't memorize to 12. So what does that mean? So the next step would be, you know what, let's do something, because now we're jumping ahead to multiplication, and with the adding there's actually foundational things that we need to understand. So to understand, but I can go to a multiplication that's a little bit easier. I mean, we can all do it in our head, but I'll show you what it looks like. The reason why is when we look at the addition table, in the addition table we have, this is one formula that I just talked about, and then this yellow is another formula that is going to be talked about. This is the tens formula. So going back to multiplication, let me do something. I mean, we could do this in our head, right? Not a problem. But to show you on the abacus, we don't memorize our 12 times table because it's just redundant. So here is 12 times 2. 12 times 2, the first thing we need to do is we need to understand is where do we put our starting point. Now, I notice in regular math, in school math, they start from the ones place. So what they do is they reorder it and they do this, right? And then they do 2 times 2 is 4, and then they do 4 times, right? But in abacus, we don't do it that way. We start with our, where are we going to start with? We're going to start with where the answer will go. So what we need to do is we need to find, it's called finding our starting point. So to find our starting point, it's 3 digits. 1, 2, 3. 1, 2, 3. So when we count it, right, we're going to start in the hundreds place. Why? Because we think the way we see the numbers, we're having a conversation with our we're having a conversation with our math. And I think that's what we're missing in regular school, is we don't have a conversation with our math. What we do is we just look at it and we just do it. No, it should be more like a conversation. Like, how many digits do we have? So we have 3 digits. Like, we're looking at it and we're analyzing it. So when we look at it and we analyze, right, I see that I have 3 digits. So I think that the number will be over here on the hundreds column. Okay, so now what would be the questions? The question is 1 times 2 is equal to 2. Well, notice it's a single digit, right? If we made this into a double digit, we have a leading 0, right? The leading 0, just like how we do the plus 4. We don't see this plus 4, but we see it, right? It's implied. So this is implied. If I have a 0 here, I'm going to do a 0 and a 2. So notice I moved my finger from the hundreds column to the tens column. And I add my 2. Okay, I'm going to keep my finger here. The next question is 2 times 2 is 4. Again, 4 is a single digit. I look for my leading 0 and I do 0 and 4. And I do that. No, you're not too dumb. I'm literally a lawyer. No, you're not too dumb. There's no harm in, there's no shame in not understanding how to read the abacus. I mean, I learned the abacus when I was an adult, and it took a long time. It took, like, why are we doing it this way? For me, I was like trying to wonder, like, why do we do it this way? But now when I'm looking at it and I'm comparing the two, notice that I started from the tens place, right? I started from the tens place and I moved forward, which was interesting. So in abacus, we go forward. We do the hundreds, tens, and the ones first. But in the regular school, we go backwards. We do the ones, then we do the tens. And I'm like, that's so backwards. So are you a math teacher that teaches math? Because I've never learned this. I am actually an abacus teacher. I don't have I have my own learning center, and I've been teaching, abacus for 20 plus years. But going into, because now TikTok's around, no, going into trying to be more on the internet, trying to be more over, worldwide, that's what WWW is, trying to be more worldwide. I wanted to be able to relate math with all the math terminologies with abacus, and I feel that there is a disconnect. and I'm the bridge that connects the two. So when I start using math terminologies, it makes a lot of sense to us now. But if you look at any of the videos on YouTube, any of the Abacus videos, they start talking about big friends and small friends. What we just learned here with the +5 and -5, that's what you call in Abacus world friends or small friends. But in mainstream school, we talk about it as the 10 frame and the 5 frame. This is a 5 frame. This is a 5 frame concept. And this 5 frame concept is finally being utilized. Like school now is starting to be more visual, but instead of being more, they build all these strategies to be more visual when in my head, if you just showed it on the abacus, it would make everything a little bit more packaged well. If that makes sense. Packaged well. So like here, there was one strategy I was looking on TikTok just to research like what they're learning in second grade math. Like in Abacus, we have our formulas, we have our phases. So we do, simple first, which is all the green, right? And then we do the +5, which is all the pink, 5, which is all the pink. Then we do the +10s, which is a 10 frame, and that's like all the yellow. And then here is another terminology that I've just discovered. This is what we do with a two-step equation. Now, what do you think of them apples? Cohesive. Yes, cohesive. Or yeah, could be cohesive or well packaged. But see, that was the thing, like understanding like this, if you know this, like if you just know this table, I'm not going to give you the whole table, but if you know this table, you can easily do any adding and subtracting. It doesn't matter. You can just do it all because this is all we need. This is all we need. And it was mind blowing to know that this is all we need. And it was just those amazing thing like when I was going down this path and I just started working through the numbers and stuff. I mean, we're just doing two add-ins, right? The first add-in, the second add-in. But in Abacus, they go like 10 add-ins and sometimes they mix in some subtract heads. And I'm like, this is all strange terminology, but it's something that we need to know. It's something that, using the abacus, we need to understand how to relate all of the stuff that we know in abacus. How does it relate to mainstream math? Yeah. So, in this book, I have my preschool abacus. You can look for it on Amazon and you can search for my name. But in here, in the beginning, I did preschool because that was one of the gaps. One of the gaps was in abacus, like in the abacus world, we only teach children that already know their numbers. So what I did, yes, I will calculate more. But I just want to continue on with this thought. So in my worksheet in this book, what I did is I wanted to, show the difference between like how to relate the numbers with the abacus and how does it look. And so we talk about, and then I have it where there's activities just to reinforce the idea of what the abacus looks like and what the number looks like, and like adding some subtraction. So is the big abacus you have behind you? Yes. So okay, I'm sorry. Let me continue my thought. So here they talk about, they count forwards and they count backwards and so forth, and they count like which one's bigger and which one's smaller, and then we start doing the adding and subtracting. So here we add, and once we learn how to add, we have to learn how to subtract. Right, like the next lesson is learning how to subtract. So we have adding the one, and then notice I only do like the specific number. So what does that mean? Well, when I do the number, I want to add the 4, but I want to see what does 3 beads take away. So I take away 3 beads. So the idea is to see the beads move from here to here, right? If I had 8 and I want to move 3 beads, I can move these 3 beads. It doesn't matter. Okay, so that's what that is. Okay, so the big abacus, yes. There's 2 big abacus. This abacus, these abacus, you'll see in some of the videos in. Sometimes you'll see in my videos or you'll see in other YouTube videos. This is the teacher's abacus. Why is it a teacher's abacus? Because it can be vertical and nothing falls, right? And the place value is movable. So I can go from here to here to here, but this is still my dot, right? This is still my label. My label is for labeling where the ones is, because depending on how big your abacus is, It depends on where your dot is. Would I recommend it? If you're a teacher, then this is a great tool. If you're just a parent, it's a little much. just just so you know. But it works the same. We still have the 4 beads, right? 4 beads on the bottom, which is 1, 2, 3, 4. How do I know this is where I am? Because I have my marker here, right? And then I have my 5, which is my top bead. And my top bead is still the same, right? Whatever's above the horizontal bar, right? We call it the beam, but as people go through and not understanding what this is the horizontal bar. So this is the horizontal bar that gets counted. So we do 5, and then 6, 7, 8, and then 9. And then we have 10. It's still the same thing because we still do place values. 1, tens, hundreds. I'm over here, right? But you'd be in the middle somewhere, but then my face would be cut off. All right. So, more numbers. So let me see. I did have some that's a little bit more easy. We're going to do 3-digit counting. 3-digit addition. What do you call it? 3 lines? Three something. A little more complicated. Is it complicated? No, it's not really that complicated. Is it more numbers? It'll be more numbers. And that was the thing, understanding the terminology and how it relates to Abacus. So the question is 20, 26 plus 53. This is a very common, it's common to have 3 lines, 3 add-ins in Abacus. It's very common to have 3 add-ins. So, again, we have our Abacus. We could do it here because we have enough columns. So we have, but here we don't need to count how many columns. We're not like that in multiplication because we're just going to go down. But instead of going to the 1s and then the 10s, we actually start and we do the whole number. We don't, in school, right, we don't do this and this, right? In Abacus, what we do, let me get a green one. In Abacus, we actually do it by number. We do this and then we do this. So notice I do 20, 2 and a 0. And then I do 26. I do 20 and I do 6. And then I do 53. I add 5 and then I add 3. So when we add an Abacus, we do the number as a whole. I mean, you could do it like in school, but then you would get confused because sometimes there'll be like 10 add-ins and then you'll be like, oh, I did all of this, now what I do, and I got to carry the 1. So in this way, the way we work the numbers, yes, it is so much easier on the Abacus, and you can see it too. And that was the one thing I really liked, is that you could see the numbers, because I mean you could break it up, right? So the idea was, if it was 20 plus, if we had the numbers like this, right, you could say, okay, this is 46 because it's 20 and then 0 and then 2 and then 6. So you could say this is 46, and then you can, I mean, it's a lot more to write it out, but you could do that, but writing it out is, I mean, if they do it on the Abacus, it's kind of the same. So I counted and I got the number before I added the numbers up, and I was right. Yeah, fantastic. Yeah, yeah. So, and that was the thing, is we could do other things and stuff. So, is there any more? Oh, so I'm going to do a few more. So here's another question we could do. Now we're going to start going into it's called the 2-step, let's not do the 2-step yet. So let's do 6 plus 5, 7, 3. Let me see if that's a 2-step. We'll see if it's a 2-step. So we add the 6. So we add the 6. Oh, this is good. So we add the 6, right? And now we add the 5. There's not enough beads to add the 5. Anybody remember? Anybody? No, I can't take that. I have to take that back. I don't know how long it's been that they were teaching the 10 frame. A lot of it is how to make a 10, right? So what we're doing is we're going to add this 5. To add the 5, we need to learn how to make a 10. So we know that 5 plus 5 is equal to 10. That's not a problem, right? So then what we're going to do is we're going to move that over here. So then we rewrite the question. It'd be, because we're isolating the variable. The variable is this variable that we want to isolate. I'm just so tickled by all the math terminologies that I'm finally discovering. I mean, I knew of them, but I didn't didn't connect it to the abacus. Anyways, so we isolate the variable, so it's plus 5. The reason why we say plus 5 is because we want to be reminded that we're adding the 5. So we're adding the 5, it's plus the 10, and then minus the 5. So we know that we're going to, so this 10, okay, oh, that was another thing that I made a connection. This 10 is like a carrying over. So we just carry over to the next column. See how I'm very, anyways. So when we do the 10, we carry over to the next column. The 10 always is a carryover. That's what 10 means. That's so brilliant. I'm sorry. Okay, so we add the 10, and then here we say we minus the 5. Okay, so what's the difference? Well, the difference is learning how to connect on the abacus and learning how to use the math terminologies that's being used in everywhere else in America. I'm talking about America because that's all I know. I mean, I'm not sure how it's being taught in Europe or other parts of the world, but I just wanted to mention. So we're now here, right? We're now adding the 7. Now the question is I'm back to here, right? Because I need to add 7. It's still a single digit. I'm still in the ones column, right? Even though I have this tens, right? I still go back to here with the ones. And my question is there enough beads? Yeah, okay. We also do that in Norway. Okay, so we do a carryover. So then it's a math terminology. And so then what I'm trying to do is I'm trying to put math terminologies with abacus for adults to understand. Because that was the one thing, like, it kind of blew me away. Like, I've been doing abacus for more than 20 years, but only now did I start to figure out how to connect everything to what mainstream math is. And we don't use the same terminologies. We say big friends and small friends. But here we do carry on. So we're back to here. So the question is do I have enough to add 7? Yes, I have enough to add 7. How do I know? We have 5, 6, 7. So I add the 7 like this, right? So my next question, my next number, right? Notice it's 3. Now, do I have enough to add the 3? No. The question is, can I add 3? No. The next one, which is one of the 5 frame, because we want to know is the next step is to add the 5 frame. Is there enough to add the 5? No. So what's the next one? Again, it goes back to adding, making a 10. So it's 3 plus 7 is equal to 10. Again, we're going to isolate the variable, right? This is the variable we're going to isolate, and we move the 7 over to the other side of the equation, the other side of the equal sign. And so it works just like in algebra, right? When we start moving things over. So when we rewrite this, it's a 3 is equal to plus the 10 minus 7. So we need to plus the 10, which is again carrying over. So we carry over to the 10, and then we take away 7. And my answer is, what's my answer? Who tells me what my answer is? Anyway, let me stop moving the abacus. Okay, what is this answer? Yes, 21. Easy, right? So easy. Yes. Let me get the sound effects. Let me see. Clap. Yes. I'm really getting into this TikTok stuff. So yes, fantastic. 21. Exactly. So does it make sense? So I mean, you could do it. What was another way? The other way was you get a bunch of blocks, right? And then you put them all together, and then you start grouping them. So if we did 6, 1, 2, 3, 4, 5, 6, right? And then we did 5. I need more blocks, right? We do blocks, right? We could do, okay, so we have 6. We have our 6 here. 1, 2, 3, 4, 5, 6. You could do this, not a problem. You do 5, so I add the 5, right? And then I have my 7, so I have my 7, right? To see the amount. And then we have 3. And then what do we do? Well, now we got to figure out our 10s, right? Every 10, right? We could do every 10. So, and we trade it, right? They call it grouping and regrouping. We don't really regroup in Abacus. We do a carryover, but we don't really group and regroup. I mean, I guess you do. I guess we do. We do grouping and regrouping. We don't call it that. So, I mean, if I did this and then I group it, because the idea of grouping, right, is making our 10. I'm not counting. I'm just trying to see. So I group it, right? So then I'm taking this 10 out. And then I do another 10. right? So this is another 10. I think I did that wrong. Yeah. And then I throw that away, and then there's 1. I think I did it wrong, but I mean, you know what I mean. So it's 3 of them. Yeah, go ahead. Yeah, okay. Have a good night. Good. Thank you so much to show me. I never, then nobody ever explained it. Oh yeah, that was the one thing. Is like nobody ever explained it. Have a good night. I will see you later. I do plan on going in the morning, so maybe you can catch me when it's your afternoon or early morning. Something like that. So have a good night, and I'll see you soon. Thank you so much for everything. Thank you so much for the questions. It was fantastic. Yeah. So I think I did that wrong. 6. Anyways, I'm not gonna worry about that. But we talk about grouping, regrouping, and we do that on the Abacus. We also do the carryover, and that's what this is. So doing this 10 is a carrying over. I would teach it with the kid. I wouldn't teach it with the kids. If they do Abacus, they learn Abacus, and then maybe later when they go into regular math and regular school, they'll see it as a carryover. But I would. I don't know. I don't know if I would teach. I don't know if I would add that is. Maybe I do. Maybe I do say it in my language when I create my workbook. I didn't add it. I just started thinking about it, and so yeah, so maybe I'll do add the terminology of carrying over, because they do it in textbooks. So if they do it in textbooks, I can do it too. Not a problem. I could do it. I should do it. But that'll be in the next book, because I already did my plus 5s, and then I already did the plus 10s, which is over here. And I already did the plus 10s, and then I got to work on the plus. I got to work on the minus 5s, and I got to work on the minus 10s, and I got to work on the two-step equations. I mean, there's a lot to the numbers. It's just understanding it and knowing how everything works. So, yeah, 3 a.m. is really late. I hope you laughed. It's really late. For me, I'm in LA. I'm in California, Southern California. So it's only 5 p.m. So it's only 5 p.m. for me. Oh, I've been on for almost an hour, and when we've done a lot. Anybody have any questions? Uniquely you by you. Talisha May. Hello. Hi, everybody. And H. And in CMS. In CMS. Yeah. Anybody else any questions? But I can continue on with like the books and stuff. So these books are available. I'm still in the process of getting out some other stuff. I've been excited to go live. It's just fun to be able to have a conversation about Abacus and how it relates to school. And so this book is all of these books are available. I'm on my 7th book, but I mean, I don't know if anybody's interested, but I also have a coloring book, and it was kind of boring. Like I started off like kind of boring, and then I was like, well, what is another way to make it exciting? So I started doing some crazy coloring, and I was like, oh, I could do this with my coloring. I mean, I'm not fancy like all those other people that do coloring with the Cocoyo, with all that brush strokes and stuff. I grew up with Barbie and the coloring book, but they take it to the next level, and so. But this was just something like, kind of go through if you want to take a break, but still learn how to read the Abacus. So I had it where you color the frame, right? This is the frame. Again, this is the horizontal bar. And then I have the top bead, and then we count the top bead with the low beads. And then I kept it with the regular Abacus. In my other one, and if you guys want, this is available. There's a calendar that I created, and this calendar is for 2025. We're still in February, so you're gonna get the February, the month of February. And I added like prompt questions, and in the prompt questions, it's just like, what is today? What is tomorrow? What day is yesterday? And then these are just to help the children to understand, their calendar. And with the calendar, I added there's the quarterly calendar, and then I have it where there's the monthly calendar, and this one is February, and I did simplified Abacus, which means that there's not the extra beads, because sometimes it's a little much. If you notice, like this one is the regular Abacus, and notice there's a lot more beads. So it gets a little, it's a lot for the kids to see, depending if they're used to it or not. So I give you two versions, one to look at it, just the counted beads, and then one with everything. So that's the regular. And that was the calendar. So that's in the link in my bio. If you are welcome to have, just to bring in some Abacus into your classroom, your daily life, or what have you. It's just another thing to get to the kids to understand, how to read the abacus. And, obviously it goes into the double digits, like, 20, 30, 20 and 30, right? So there's the 20, 27. And so you can kind of see the progression from like 9 to 10 and then 11. So, yeah, that's what I have. And then, I mean, I obviously I have this, but it's no longer Halloween. But I do have a Halloween one. This one's really focused on figuring out what the numbers are from 0 to 10. And again, we start from 0 because we want to make sure that our abacus is clear. So if our abacus is clear, then we know that that's zeros. And then it comes into, doing a maze, and then I like the maze. So this one is a maze where I wanted to do number recognition, bead recognition, and word recognition. And then here, which is the manipulative. What manipulative? Well, this one was supposed to be dough balls. I couldn't say Play-Doh because Play-Doh is a trademark. And so what I wanted them to do was use the dough ball, right? And here, what it is this is 1, so color in this 1. So I would have the children to trace the number 1 and then color it in. Let me color it in orange, right? Or brown. So, and then the next question is, oh yeah, have a good night. I love your lives and how you interact with us. Yes, thank you so much for all your questions. Let me know if you have any more. But yeah, 2 a.m. is really early. But I do try to go in my time, 7 a.m., 8 o'clock, 8 o'clock a.m. I would have to figure out what time that is for you. But I was on earlier and I was just testing it out. So I'll try to go on earlier so it's easier for you to join. But yeah, my plan is to go a little bit more accessible. So yeah, thank you again. Have a good night. So here, and then the question is, where is the 1? So notice this is not 1, but this is 1. So what I'm going to do is I'm going to color it in. I'm going to color in the counted bead, and I just move down the maze, right? And then the next one is, well, where is 1? Well, that's not 1, but this is 1. So again, I have the kids to trace the number. And then we have this blank spot. That's where you get the dough ball, and you put that there. So the idea was to be interactive and to make it, okay, I'll be there. Have a good night in CMS. So yeah, and so that was the thing. I mean, like, don't color in the thing. I mean, you could, but I didn't. And so it's a maze to get to the finish line, which is down here. So that was the one thing trying to figure out. But yeah. But I do like this. Oh, so then again, this was about just number recognition, about from 0 to 10. So this is, a little bit younger, or, people, not people, but kids that have some, they want to trace the numbers and stuff. And so I have the activities where they do pairs, right? This is the beginning of pairs. How to match the number with the pair, right? The number of the abacus and the pair. The number and the abacus. That's what I was trying to say. And then counting the numbers. And then this is the haunted house. Again, we're matching the number to the abacus. So this is 0, that's 0. This is 1, so you look for 1, right? So you cut this out and then you paste it onto the ghost. Paste it onto the house. So that was the interaction. And then this one here was, again, this is a clip card. So the clip cards are not common, but a clip card was an interesting thing that I noticed. And I made this one where you cut it out, you trace the words, you cut it out, and you get these clip cards. That's what these are. So you get the clip card, and then you try to figure out, there's many ways to work a clip card. Either you clip the number, this is the number 1, and then this is the number 1, and you clip it together. So it was to get the kids to practice, their motor skills with pinching. And so then you can ask the question, okay, what comes after 1? Well, 2 comes after, 2 comes after 1. And so then I clip it here. So that was this is the activity, and they should be 1 for each. This one is 0, 1, and 2. So what comes before 1, and then what comes after 1? So let's see. Yeah. All right. Just checking to see if anybody was calling me. So then this is Halloween based, right? And it's only from 0 to 10. And then again, I have it where there's answers. So if in case you just don't know, I mean, I have answers to all of them. And then which is more? And then you would circle in or you put in the dough balls with it. Yeah. So that was the Halloween one. And then there's the here's a Christmas one. Now, why am I showing this? Because it's the concepts that I wanted to show, right? So I have it where it goes from 0 to 20, but in this one, you do adding and subtracting, and you add and subtract on the abacus with the 2 digits. So this one was kind of cool because this one is 2 digits. So what number? So this number here is, what number is that? Anybody know what number this is? Put it in the comments what number you think this is. This is, oh, hi. So if I move it and I use it on the abacus, right, it'll be 1s and 10s. So I have my 1 here and I have my 10s here. It'd be 17. So now if I take away, right, I'm doing subtraction of 5. All I need to do is take away the 5, and that's what it is. So then my answer is 12. So that was the one thing, is to get the kids to understand what it was to take away. Yeah, and then there's matching, right? Matching the numbers with the items and the abacus, and that's what I did. Yeah. So the one thing, the reason why I'd say this, because it has the adding and subtracting as well. If the preschool one is too young, right? Because this one talks about like the relationship of the abacus, the relationship of the numbers, and that's like counting forwards and counting backwards. But this one, in the Christmas one, we don't really talk about counting forwards and counting backwards. We just talk about the numbers and then go straight into adding and subtracting. But it's kind of like sprinkled into the learning the numbers. So like this one was learning plus minus 2, subtraction. This is minus 2. So we're doing minus 2, but it's like before learning number 13. So I was trying to make it kind of different and trying to change it up a little bit. So that's what that is. So anybody have any questions? Thank you again for everybody joining me. I was just talking about Abacus. I enjoy talking about Abacus and the relationship, how everything is. And it's so interesting on how, the TikTok, everybody that joins TikTok in my lives, it's nice to be able to have a conversation about Abacus, because it gets kind of boring if it's one-sided. If it's one-sided, it gets kind of boring. But now there's a conversation. Like, let me know if you have any questions. I mean, we can talk about adding and subtracting. We can talk about multiplication. We can even do division if anybody's interested. But I have been on for about an hour, and I should kind of like log off just to take a little breather, because I think I talk a little too fast. But it is a little bit late, and we'll see. Okay, so this would be it. I will ask one more time, and then if anybody wants to carry on, I will. But if not, then I will sign off. And I want to let everybody know that I appreciate you guys, and thank you so much for joining my live. And I do. Finding the connections between mainstream math and abacus has been a very interesting journey. Like, it's just so interesting, like how so close abacus is, but we always treat abacus like it's a separate topic altogether. But it's not. It's not a separate topic. And that was the thing, is like, how does the abacus relate to mainstream math? And that's what I'm trying to do. I'm trying to relate how all the abacus that I've learned, how it relates to mainstream math. And it's been a journey. And I still make connections, but I think after a while I'll see how far the connections will go. But yeah, I do believe that abacus is the gateway to complex math. Yeah. All right. So if there's no more questions, thank you again for everybody for joining me. I will sign off, and I'll see you next time. I do plan on going live tomorrow at 7:30, but I'm not sure. It depends on what time I'll wake up. So again, if anybody has no more questions, I will sign off. Thank you again, everybody, for all your comments and questions. Have a good night. I'll see you later. Bye.